Hey guys, so today we are going to try to understand how to use Lewis symbols to write or represent chemical atoms. Series in which, so to understand this further, we need to understand the concept of shells. So what are shells? Shells basically determine the energy level. Now, because we understand from Bohr's model that electrons occupy a certain energy level, and these energy levels are represented as shells. So K, L, M and N are shells, each having a quantum number. A quantum number is used to represent their energy state. So this is represented by the letter N. So 1, 2, 3, 4. Now these shells can further have orbitals. Now, what is an orbital? It represents a subcategory or fine energy levels. You can assume them to be fine energy levels within them. Now, there are four possible orbitals, that is represented by the letters, small letters S, P, D and F, again having a quantum number 0, 1, 2 and 3. Now S can accommodate 2 electrons, P can accommodate 6 electrons, D can accommodate 10 electrons, F can accommodate 14 electrons. So each shell will further have these subshells, you can say, or orbitals. But how many will each shell have all SPDF? No. The idea is the number of orbitals that one shell can have is equal to n minus 1. So 1 minus 1 is 0. So 1 will only have one s. Now n in this case L is 2, so 2 minus 1 is 1, so it can have 2s and 2p. Now if you talk about the third, 3 minus 2 is 2, so you can have 3s, 3p and 3d. Now, whenever we talk about the chemical reactivity, we always say that it is the electrons in the valence shell. The electrons in the valence shell, that is the outermost shell, they only are the electrons there called valence electrons. Only they participate in chemical reactions and hence only they are important, right? So, what are the electrons in the valence shell? Generally, the s or p electrons we will be taking as the ones that are that are present in the valence shell. Now, this is an oversimplification. Why? Because this Lewis structure does not work for the d block elements or the transition elements. It just gets too complicated there. So this representation works for the lighter elements. Now let us write the would be filling these. So 1s, 2s. The easier way to remember the filling is this. So let us go to this. So you'll start from here and you'll draw lines like this. So this is how you're gonna fill your orbitals, right? So I'm going to do the same for a few elements and draw the structures. So now here we have the atomic number mentioned for the first few elements. So let's start with lithium. So lithium is 3. So first I'll fill 1s2. Remember, s can take 2, p can take 6, right? So 1s2, and then I have one more electron left, so that would go in 2s1. So this becomes the outermost. So how would I represent them? So lithium, I'll write the symbol Li, and I would just add one electron because this is the valence shell that we have, right? Now let us try to do the same for beryllium. Beryllium has 4, so I'll say 1s2, 2s2. So clearly here, this is the valence shell, right? This is the valence shell, and hence I would write this first of all the symbol, that is Be, and then I would write add two electrons. Now it's very important here to understand that these two are paired electrons, right? These are paired electrons, so I would write them just as them, right? So here this electron was unpaired, right? Each this s orbital can take uh, two electrons, and if both electrons are present, then it's a paired electron. So I would write it like that. Now let's talk about boron. So boron, again, first let's write it. 1s2, 2s2, 2p1. It's very important to remember this, right? So again, this is paired valence electrons. This is unpaired valence electron. So if I were to write, I'll first write the symbol, that is boron, and then two paired electrons and one unpaired electron, right? Now let's come to carbon. Again, 1s2, 2s2, 2p2. Now again, this goes the valence. So two electrons would be paired and two will be not, right? So let me write that here, here, and here. Nitrogen has 7, so 1s2, 2s2, 2p3. P can take a maximum of 6. Now, this is unpaired, very important, and this is paired. So let me first write the symbol and draw my two paired electrons, and then I'll draw the unpaired electrons. So this is how you write the Lewis structures for various elements. I hope this helped.
Want to learn more? Check out the next video. Quick reminder to subscribe to Geekly EDU.